So we have a system of linear inequality and we need to find a solution. Let's begin by first considering the inequality 2x minus 3 is less than 0. We'll transpose 3 to the right hand side to get 2x less than 3. Now what we want to do here is we want to make the coefficient of x equals to 1. So that means we will need to divide both sides with positive 2. But to do that, let me state a property of inequality. That means if we have two numbers a and b such that a value is less than b, and we also have a number c, and c is a positive number, that means greater than 0, then if we divide a with this number c and b with the number c, then the sign of the inequality is not going to change, meaning a over c will be less than b over c. In our case, we will divide both sides of the inequality with 2, and 2 being a positive number, the sign of the inequality is not going to change. So this is going to give us x less than 3 over 2. Let's label this as number 1. Next, we consider 2x greater than, so this is actually a minus 4. So 2x is greater than negative 4. Now what we'll do, we'll divide both sides with positive 2. So that means we will have 2x divided by 2. So the sign of the inequality is not going to change. And this will, on the right hand side, we have negative 4 divided by 2. So this gives us x greater than negative 2. So let's label this as number 2. Now we'll try to find a common solution because it's a system of linear inequality. For this, what we'll do, we will consider a number line, the real number line. On it, we will consider 2 points, x equals to negative 2 and x equals to 3 over 2. So from number 1 here, we have x less than 3 over 2. This means that we have to consider all the values of x, excluding x equals to 3 over 2, and it should be less than 3 over 2, meaning the solution is going to lie to the left of 3 over 2. In number 2, we have x greater than negative 2. So that means we'll consider all the values of x, which is excluding negative 2 and greater than negative 2. That means it will lie to the right of negative 2 and extend up to positive infinity. And for the case number 1, in equation number 1, it's going to extend up to negative infinity. Now, we have to find a common region. The common region means this is the common region. So this is the part. This is going to give us a value which is going to value for x, which is going to satisfy both inequality 1 and 2. So that means here, if we consider our interval form, we will take from negative 2 to 3 over 2. And this is going to be within open intervals because the endpoints are not part of the solution. So this is a solution which satisfies both the two linear inequalities.